All right, welcome to another edition of Science Bros. Today we're going to do a dehydration of a sugar. So have you ever wondered how much energy is actually in the things you eat? And one of the demonstrations we go to show you how much energy is actually in this is we can dehydrate sugar. Sugar has a lot of energy built up into its chemical bonds. And your body will break these apart and get the energy out of it. Now, this process when we're going to dehydrate it is a little different, but it's got the same basic principles of we're getting the energy out of the molecular compounds of the sugar. Now, sugar this is ordinary table sugar, and it is sucrose, which is H12 or C12H22O11. It's a sucrose and a glucose molecule that are bound together, and fructose and glucose bound together, and so it's sucrose. So sucrose, and it's mixed in, granulated sugar mixed in with an oxidizer. This oxidizer is sodium nitrate. So we're going to do sodium nitrate, and it's mixed in with the sugar. So we're going to do different oxidizers mixed in with the sugar to see how well we can get the energy out of them. And what we're going to do to start the dehydration of the sugar is to put sulfuric acid in it. And so the sulfuric acid is going to initiate the reaction. That's all it's going to do. It's going to generate some heat, and then it'll be a self-sustaining reaction when we burn through this. And that energy, all that energy, is coming from those sugar molecules that are in there. All right, let's get to it. I'm going to turn our hood on for safeties. Not too exciting yet. All right, take two. We're gonna do now sodium. We're going to do sodium chlorate. We tried sodium nitrate last time, and this is sodium chlorate. So we will have to look at. We'll take a look and see how this does. Also, some factors you want to think about is their moisture. If there's moisture in some of the compounds that we use, the oxidizing agent or the sugar, it can also change how much of a reaction we see too. So it's how powerful of an oxidizing agent we have in there, and also how much water is in there. So those two things can factor into how vigorous a reaction we can see too with this dehydration we're trying to achieve. So all right, let's get on to the sodium chlorate. Okay, so here we go. Some sulfuric acid in there, and then we'll hopefully see some fireworks. We definitely saw some fireworks there. Wow. Never a dull moment here with the Science Bros. We had a breach of our containment vessel there on the last one, and we did sodium chlorate. Now we're going to do potassium chlorate as our oxidizing agent here. So we've made another vessel to hold it. We have a piece of iron here, steel, and we've got the sugar and the oxidizing agent, the potassium chlorate, already mixed there on it. So we're going to do this again, and or do this new one, and see how well it works. So let's get that sulfuric acid on there. Hood on. Pretty sweet. Even more vigorous, I would say, although we did spread it out, so there's more surface area for that reaction to occur faster. So it's a difficult comparison. I would say overall, I would say it's a more vigorous reaction, especially with it being potassium chlorate as opposed to sodium. Potassium is a little lower on this list, a little more easier to oxidize this with. But so it's a slightly more powerful oxidizing agent, but the surface area played a role in that as well. But hopefully you also got to see that characteristic purplish flame from potassium that's in there, if you recall the Science Bros flame test. So you might have got to see that little characteristic color in the flame of that one. So, sweet.
All right, so we're going to do one final reaction here. We have a little bit of excess sulfuric acid, so we might as well use it up as much as we can. So what we're going to do here is actually one of my favorite reactions. And this is going to be a dehydration of sugar again, but it's actually going to produce this kind of cool little effect that you'll see here in a second. It's one of my favorite reactions. I do this every year with my chemistry and physical science students. And it is going to be a decomposition reaction. So what that means is basically the sugar is going to be broken down. We're going to use the sulfuric acid to create this reaction where we are going to break down the sugar. And what I mean by that is we're going to separate the chemical bonds. What we're going to do is we're going to take sugar, which is C12H22O11, and we're going to break all of those carbons off of it, all those 12 carbons. What we're going to do is separate those out into pure carbon and a little bit of water, because if you break all the carbon off of sugar, you're left with H and O, and then there's H2O, so we're going to create a little bit of water here. So that's going to be our two byproducts, are going to be pure carbon and H2O. There's actually quite a few reactions going on here, but the one we're really going to focus on today, and the main one, is the decomposition reaction. Again, that sugar is going to be breaking apart. We're physically going to separate those carbon bonds. So what we're going to do here is we're actually going to take the sulfuric acid and we're going to dump it directly into the sugar. There's nothing else in there. There's no potassium nitrate, no potassium chlorate, no oxidizer of any kind. And we're just going to dump this sulfuric acid directly into our table sugar, and we're going to see what happens. This reaction does take a little bit of time to get going, so just bear with me here. So you're seeing all this vapor here. What do you think that could possibly be? We just said there's two byproducts made. There's pure carbon, which is exactly what this black column here is, and there is water vapor being produced. That's that steam there. This is a very exothermic reaction. It produces a lot of heat. So because of that, the water that is being created, the water that's being liberated from the carbon here, is actually just boiling away, and that's where you're seeing this water vapor here. So that's a pretty cool reaction. Again, just a dehydration of sugar, just on a grander scale. And you might be asking yourself, well, why does it form this column? Well, realistically, it's forming this column because this carbon is actually kind of rigid and also a little bit brittle, but it's forming this column because the beaker kind of creates a pathway for it to flow up. And if you just did this in a pile on the top here, what you just see is maybe just a bubble of carbon form, but it creates this nice column because we have a beaker to kind of guide it. And I did have to give it a little bit of help to guide it up, and I can't really feel this or anything, but technically after it cools down and after it's set for a while, it is safe to touch, and it kind of feels weird because it's really brittle. You can break this off very easily, but yeah, that's just it. Hope you enjoy the video.